Arc fault circuit interrupters, or AFCIs, are generally reliable but can occasionally experience nuisance tripping, especially if there are significant electrical loads or electromagnetic interference. They are designed to be more sensitive than standard circuit breakers to prevent arc faults, which can be a fire hazard. Installing AFCIs throughout the house can provide enhanced protection against electrical fires. Electrical fires are a significant cause of residential fires, and AFCIs can help detect and interrupt arc faults, which are often the precursors to fires. The additional cost of AFCIs may be worth the peace of mind they provide. AFCIs require a separate neutral conductor for each circuit. This is because they use a ground fault or neutral current sensing technology to detect arc faults. Without a dedicated neutral, the AFCI cannot properly operate. Building codes vary by jurisdiction, but in many areas, AFCIs are required in certain locations, such as bedrooms, living rooms, and family rooms. It is likely that codes will continue to expand the use of AFCIs in the future. There are some additional considerations to keep in mind. Firstly, cost. AFCIs are more expensive than standard circuit breakers. Secondly, availability. AFCIs may not be readily available in all locations. Thirdly, compatibility. Ensure that the AFCIs purchased are compatible with the electrical panel. Fourthly, installation. Proper installation is crucial for the effective operation of AFCIs. And fifthly, maintenance. Periodic testing is recommended to ensure AFCIs are functioning properly. Overall, AFCIs can provide enhanced electrical fire protection. While they can be somewhat more expensive and require additional wiring, the potential benefits in terms of safety may justify their use throughout a home. An AFCI is a circuit breaker that breaks the circuit when it detects an electric arc in the circuit it protects. AFCIs are designed to protect against fires caused by arcing faults. An arcing fault is an unintentional electric discharge between two or more conductors. Arcing faults can occur in damaged or deteriorated wiring, loose connections, and electrical appliances. AFCIs work by detecting the unique characteristics of arcing faults. When an AFCI detects an arcing fault, it quickly shuts off the power to the circuit, preventing a fire from starting. There are two main types of AFCIs: branch or feeder AFCIs and outlet circuit AFCIs. Branch or feeder AFCIs are installed in the electrical panel and protect the entire branch circuit. Outlet circuit AFCIs are installed at the outlet and protect only the outlet and any devices plugged into it. AFCIs are required in many areas by the National Electrical Code, or NEC. The NEC requires AFCIs in all branch circuits that supply bedrooms, living rooms, dining rooms, family rooms, dens, and recreation rooms. AFCIs are also required in arc fault protection devices. The NEC also requires AFCIs in dwelling units. To choose the right AFCI for an application, firstly determine the type of AFCI needed. Branch or feeder AFCIs protect the entire branch circuit, while outlet circuit AFCIs protect only the outlet and any devices plugged into it. Secondly, consider the amperage rating of the circuit. The AFCI must have the same amperage rating as the circuit it is protecting. Thirdly, make sure the AFCI is compatible with the electrical panel. Fourthly, select an AFCI that is listed by a qualified testing laboratory, such as Underwriters Laboratories or all. To install an AFCI, firstly, turn off the power to the circuit at the electrical panel. Secondly, remove the old circuit breaker or outlet. Thirdly, connect the wires to the AFCI according to the manufacturer's instructions. Fourthly, install the AFCI in the electrical panel or outlet box. Fifthly, turn on the power to the circuit at the electrical panel. To test an AFCI, firstly, plug a test device into the outlet. Secondly, press the test button on the AFCI. Thirdly, the AFCI should trip, shutting off the power to the outlet. Fourthly, reset the AFCI by turning it off and then back on. AFCIs should be tested monthly to ensure they are working properly. AFCIs are an important safety device that can help prevent electrical fires. By following the above tips, selecting, installing, and testing AFCIs properly will protect home and family. Here are some additional details about AFCIs. AFCIs are designed to detect a wide range of arcing faults, including series arcs, parallel arcs, and ground arcs. A series arc is an arc that occurs in a single conductor, such as a broken wire. A parallel arc is an arc that occurs between two or more conductors, such as a short circuit. A ground arc is an arc that occurs between a conductor and ground, such as a wire touching a metal pipe. AFCIs use a variety of technologies to detect arcing faults, including current sensing, voltage sensing, and waveform analysis. Current sensing AFCIs detect arcing faults by monitoring the current flowing through the circuit. Voltage sensing AFCIs detect arcing faults by monitoring the voltage on the circuit. Waveform analysis AFCIs detect arcing faults by analyzing the waveform of the current and voltage on the circuit. AFCIs are designed to be immune to nuisance tripping caused by normal household appliances. However, some appliances, such as vacuum cleaners and power tools, can generate electrical noise that can cause AFCIs to trip. If an AFCI trips frequently, it may be necessary to replace the appliance or the AFCI. AFCIs are a valuable safety device that can help protect homes and families from electrical fires. It is important to understand how AFCIs work and how to select, install, and test them properly. Some common misconceptions about AFCIs include that they are too expensive. While AFCIs are more expensive than standard circuit breakers, the cost is relatively small compared to the potential damage caused by an electrical fire. Another misconception is that AFCIs are not reliable. While AFCIs can occasionally experience nuisance tripping, they are generally very reliable. A third misconception is that AFCIs are not necessary if a home has ground fault circuit interrupters or GFCIs. While GFCIs protect against electrical shock, they do not protect against arcing faults. AFCIs are designed to protect against arcing faults, which can cause electrical fires. AFCIs are an important safety device that can help protect homes and families from electrical fires. It is important to understand how AFCIs work and how to select, install, and test them properly. When dealing with AFCIs, there are several key considerations to keep in mind. Firstly, ensure proper installation. Correct wiring and connections are crucial for the AFCI to function effectively. Incorrect installation can lead to nuisance tripping or, more seriously, failure to protect against arc faults. Secondly, be aware of compatibility issues. AFCIs must be compatible with the electrical panel and the specific circuit they are protecting. Using the wrong type of AFCI can result in malfunctions or a lack of protection. Thirdly, test regularly. Regular testing, typically monthly, is recommended to verify that the AFCI is functioning correctly. This can be done using the test button on the AFCI. Fourthly, address nuisance tripping. If an AFCI trips frequently without an apparent cause, it is important to investigate the issue. Nuisance tripping can be caused by various factors, including faulty appliances, loose wiring, or electromagnetic interference. Resolving the underlying cause can prevent unnecessary interruptions and ensure the AFCI remains effective. And fifthly, understand code requirements. Stay informed about local and national electrical codes related to AFCI installation. Code requirements may vary depending on location and the type of circuit being protected. Complying with these codes is essential for safety and legal compliance. In summary, AFCIs are valuable devices for enhancing electrical safety, but proper installation, compatibility, testing, and troubleshooting are necessary to maximize their effectiveness and minimize potential issues. Here are some of the common causes of AFCI trips and how to address them. Firstly, faulty appliances. Appliances with damaged cords, frayed wires, or internal faults can cause arcing and trigger the AFCI. Solution: disconnect the appliance and have it inspected or repaired by a qualified technician. Secondly, loose wiring connections. Loose connections in outlets, switches, or the electrical panel can create arcing. Solution: tighten all wiring connections and ensure they are properly secured. Thirdly, overloaded circuits. Overloading a circuit by plugging in too many devices can cause excessive current flow and lead to arcing. Solution: redistribute the load by moving some devices to a different circuit or upgrading the circuit capacity. Fourthly, electromagnetic interference or EMI. EMI from nearby electronic devices can sometimes interfere with the AFCI's detection circuitry and cause it to trip. Solution: move the source of EMI away from the AFCI or use shielded cables and filters to reduce interference. Fifthly, moisture or humidity. Excessive moisture or humidity can create conductive paths and cause arcing. Solution: identify and eliminate the source of moisture and ensure the area is properly ventilated. Sixthly, old or damaged wiring. Old or damaged wiring can develop insulation breaks or other defects that lead to arcing. Solution: replace the old or damaged wiring with new wiring that meets current safety standards. Seventhly, incorrect AFCI installation. Incorrect wiring or improper installation of the AFCI can cause it to trip unnecessarily. Solution: review the installation instructions and ensure the AFCI is wired correctly. If needed, consult a qualified electrician. Eighthly, faulty AFCI. In rare cases, the AFCI itself may be defective and prone to nuisance tripping. Solution: replace the AFCI with a new one from a reputable manufacturer. By addressing these common causes of AFCI trips, a homeowner can minimize disruptions and ensure the electrical system is functioning safely and reliably.